Hello, London. Hey, I'm actually an ex-Londoner, but hey. Hello, London sounds good. So, going to introduce you to Groovy for Java developers. But before I get started on the main presentation, I want to say kind of what it's not. It's not a, here's how you program Groovy. If you want to learn how to program Groovy, Groovy books, go online and check the Groovy blogs, the website, the user guide. And if you know Groovy, it's not going to go in-depth into Groovy at all. Okay? This is really for people who have heard of Groovy or haven't heard of Groovy, but don't really know what it does. Or perhaps you've looked at Groovy 5 years ago, and what have you, and interested to know, has anything changed? So what I'm here for is to answer a very simple question. Why the hell would you use a language called Groovy when it brings to mind Austin Powers every time you talk about it? Don't worry, it wears off after a while. After the first year, Groovy came to my lips easily. I didn't even think of Austin Powers. So, yeah, why would you use it? Can you take it seriously? I'm here to mention that, yes, you can. So, most of this presentation will be live coding. I'll show you some examples. But I'd like to set out some fundamentals first, some background to Groovy itself, so you understand what it is. So, it's an object-oriented language with a Java-like syntax. It's simple and expressive. You're going to see examples of this. It's optionally typed. It's kind of unique in this regard. You can have compile time type checks or not. It's up to you. So that's it at a very high level. It's always important to remember that it's a compiled language. Even when you're dealing with Groovy scripts, it will be compiled to bytecode. So that means it runs on the JVM because you've got the Java bytecode. So you can even run it with the Java command. All you need to do is add the Groovy jar file onto your class path. And that's it. You can run anything that's compiled, any Groovy that is compiled. So, where do you get started? Well, there are several options. I'm going to demonstrate the first of these. Go to the web console. It's on Google App Engine. You just try Groovy scripts. Very simple. Go show you an example. Alternatively, you can grab hold of the Groovy development kit, similar to the JDK. You install that, and that gives you access to a Groovy command line and an interactive console and an interactive shell, a REPL type thing. Okay, so that's manual. Alternatively, all the cool kids are actually using something called GVM, the Groovy Environment Manager. Has anyone heard of RVM, the Ruby Environment Manager? Has anyone used it? For you guys, it's basically the same thing, but it works with Groovy, Gradle, Grails, and a bunch of other tools. So that's the one. It relies on Bash, but interestingly, if you're on Windows, I apologize, first and foremost, but there is now a GVM Posh, which is actually GVM for PowerShell, so you don't even need to install Cygwin, which is very neat, very cool stuff, community contribution. Okay, so if you don't want to install all of that, you really only need the GDK if you want to run scripts on your local machines. If you want to use it as part of a project, you can use your IDE. All of these have great support for Groovy. It goes beyond syntax highlighting. They do all compile the Groovy and will show you errors. You also have Maven and Gradle support. There's Ant support if anyone's still using Ant. I guess some people do. So that's the background. Right. I want to start with a simple demo of the Groovy app web console. Here it is, groovyconsole.appspot.com. And now I just want to implement a simple method. Groovy powers of 2. So this is, give me the 2 to the 0, 2 to the 1, 2 to the 2, etc., up to 2 to the n. Very simple. This is the Java way of doing it. This is Groovy code. Who would automatically write something like that to do a powers of 2 method? Anyone else? I would do it. Have you all moved to Java 8 already? Yeah. People have moved to Java 8. Okay, fair enough. This is what you would do before Java 8. But ultimately, what we're looking at, we need to rethink the way that we approach certain problems. We don't want to have to mess around with determining how to get a list of the powers of 2. What we have is an existing list of the numbers 0, 1, 2, 3, and we want to map to these other numbers with a function, the function being 2 to the x. Okay? Now, this is described in Groovy using a method called collect. So let's copy this one. Not copy paste, not working terribly well. There we go. And instead, we have return 0 to n, collect 2 to the power of it. Okay? And this gives us exactly the same behavior as we had before. If I execute that, I get the output, which is 1, 2, 4, 8, and so on. I'll change that to 6, just in case you don't trust me. Watch the number 128 disappear. There you go, it's gone. So I did actually execute it. Now, this demonstrates already, this very simple example already demonstrates some core aspects of Groovy that are interesting to you as Java developers. Now, you will go, Java 8, I can do that. And in fact, Java 8 names the method properly. They call it map. What's this collect business? It's a good question. I think it's historical. I wished they called it map as well. It makes more sense. But the key advantage with Groovy here is I can run this on Java 6, and it will still work. So I get the expressiveness of the Java 8 Lambda functions, but on earlier versions of the JVM. And also, the thing that's being passed to collect is not a Lambda function, it's something called a closure. They're actually more flexible and powerful than Lambda functions. I won't go into too much detail. Some of you may have had a look at the functional Groovy talk earlier, the quickie. And Andres Almire went through some of the examples where closures are different, have more features. But what are the other aspects of this that are important to you? List. That is a java.util.list. Groovy is based on the JDK, the class library. The class library you are familiar with. Now, if you have actually learned another language, like Ruby or Scala or something like that, you know, how hard is the syntax? It requires a bit of work getting used to the syntax, but a lot of the work is learning a whole new class library. Trust me, that takes time. So one of the key advantages of Groovy there is that you're using the JDK, the one that you're already used to. But of course, collect, you know, isn't available on list. It extends the JDK. And of course, this means that when a new version of Java comes out, you get it with Groovy as well. You also see that you can use explicit types. You know, I'm using int for my method argument. I'm using list for my return value. But down here in the commented out section, I'm just using def. I'm saying I don't care about declaring the type. Okay, so that's a very, very simple example. And at this point you go, yeah, okay, it looks nice. You can do some funky things, but what am I going to use it for? Because my manager is not going to let me use this stuff in a real project. And that's the case. Or managers, teams, tend to be very nervous about using a new language in a project because they're uncertain. You know, is it reliable? Is there support for it? And so on. So I'm going to show you some examples where it's really useful without actually scaring anybody off. And the first of those is scripting. So I'll clear this off. So I have the Groovy command line, like so, running the latest, 232. Actually, the latest is 233. And what I'm going to do is write a script, something that's fairly trivial, but does some nice things. I'm going to write a text analyzer. So I have it open here. Okay. So what I'm going to do is take a text file and an optional string. I'm going to load that text file, count how many characters are in it, I'm going to count how many words are in it, and then, if a string argument is given, I'm going to count how many times that is in the text. The text file is just going to be a straightforward README. So you may think, okay, I'm going to load this file into memory, this text file. I'm now getting cold shivers. I'm used to Java. I'm going to have to open a file output stream. I'm going to have to use try finally. I'm going to have to do all this horrible stuff. It's hard work. I get the shakes whenever I think about doing this stuff in Java. But it is as simple as new file, give you the path, text property will load it into memory, and there you've got the string with the content in it. Yes, this is going to have trouble with 4 gig files. Don't do that. But it works for a simple example. So the char count is simply the size of the string. I'm going to use something a little bit noddy for the word count, which is going to be non-word characters, split on non-word characters, on series of non-word characters. And then, again, size. Notice I'm using size for everything. The string length, the array length, list length, it's always size. It's a level of consistency that Java is missing. I really do wish that they sorted this out in the JDK. The Java class library should make this consistent. And then I'm going to get some stuff I prepared earlier. 1 second. String count. There we go. That's the one. OK, and for the actual counting of number of strings in the text, just use text.count. Again, another method added to string by Groovy. If I run this, Groovy, what's the name? Text analyzer, lazybones readme, and I search for there, I get my output. So with just like 6, 7 lines of code, I've actually done something fairly useful. If you are used to writing scripts in Bash, who writes scripts in Bash? I write scripts in Bash. Every time I go, so about half of you, a third to a half of you, I mean, don't you find that every time you try to write a Bash script, you spend like an hour or two trying to remember how to do things in Bash? Well, you know that you're doing Java day to day. You already know the class library. It's just so much easier to write scripts in Groovy. And it gives you the kinds of features that you need for scripting. Loading a file into text string, stuff like that. OK, so we'll just finish this one off. Let's say, heaven forbid, that you actually want to generate an XML report from this. I know, again, this is sending shivers through me. I haven't had to do XML reports in a long time. But let's say you do want to do it. Then we can do this, create our new file with writer. Remember, I said, with Java, typically, there's the new try resources, close with resources. But if you don't have access to that, you would have to resort to try finally and nested try finallys. With writer is a Groovy method. On file, that will open the writer, and it doesn't matter whether the code inside errors out or not, it will close the stream. So you don't have to worry. And then the main item I want to show off is Markup Builder. So generating XML from code, I don't have to load in an extra library. I don't have to create bound objects. I don't have to use JAX-B or anything like that. All I have to do is say, for my builder, I want a root element called report. Inside there, I want a nested element called char count with the char count in there. So now, if I run that, yeah, I don't have report in there. If I do Groovy again and show you the report. What? Text and what was it? I'm lost. I'm not following. Oh, text report. Thank you. Sorry, I'm slow. It's been a long day. This is, yes. Thank you. There you go. And what I was actually demonstrated also is that very easily I can include conditions in the in the markup builder. So I say if string count. So if you want to generate XML, generate JSON, or even parse them, it's very much easier with Groovy. Okay, so it's great for scripting. What happens if you need access to Java libraries or anything else? You know, it's hard to include absolutely everything you need in a language and in its class library. So one example I have here is that I want to access a RESTful web service, Google Maps. So let's have a look at that. It's REST example. There we go. And I want to use a library called Groovy WS Lite. But maybe I want to use Jackson and async HTTP client, or maybe just Apache HTTP client. These things do not come packaged with Groovy. So does that mean life is going to be hard? I remember the days of having to manually add the jar files onto the -cp command line, and it's just like tedious. And you go run, that's missing, add another one, run, so on and so forth. Fortunately, with scripts, you can hook into Maven-compatible repositories with an @grab annotation. So now we're saying, I depend on Groovy WS Lite library. Please make it available on the class path. And that's exactly what happens. And now I can just instantiate REST client and use it to talk to Google Maps. So if we have a look at what Google Maps gives us, we're going to use a JSON builder class. This actually comes with Groovy. And on the response, there is a JSON property, and I want to make it pretty. Okay. Let's see what Google Maps gives us. Groovy REST example. There we go. It's pretty horrific. Oh, no, it's... Apparently, I've been using Google Maps too much today. I must have run this like 10 times. So, ouch. I'm not sure what I can do about that one. Can someone give me another new IP address? Just off, no, don't worry about it. Okay, anyway, Google Maps gives you some pretty horrific JSON. I'm not going to be able to demonstrate this, unfortunately, because it's quite nice. But if we have a look at the code down here, it's, we give our REST client our response.json. We can navigate the JSON text as if it was maps and lists, because that's all JSON is. It's maps and lists. And Groovy allows you to navigate with dynamic properties. So JSON has a root, the JSON actually has a root property called results. So we just use the results property. We can use collect, Java 8's map, to pick out the address components and give us a new list of address components. And then we can interrogate the long name. So it's more impressive when you actually see what it does, but this is a great way of extracting information from JSON. You're given the tools to say what you want to achieve, and you don't really care how that is achieved. I'm actually specifying what data I want to print out here. Okay, so this is scripting. Even if you use Groovy for nothing else, this is a very, very powerful tool. And all of those things, accessing REST services and the like from scripts, that's available to you in normal Groovy classes and projects as well. So where else would you want to use it? You know, you've been using of scripting, you love it, you'd love to use it in real projects. It's still hard to persuade people to put it into production. So the next step of introducing it is tests, because everybody writes unit tests, don't they? We're all TDD aficionados here, aren't we? Okay, I try. I'm not very good at it. But I still always try to write tests. And I actually started writing tests a lot more readily when I was introduced to a library called Spock. So I have a simple Spock project here. So notice I'm using STS. You could use Eclipse with the Groovy plugin. You could alternatively use IntelliJ and NetBeans, as I say. So I've got a couple of Java classes. I want to test those. Do I need to use Java to test Java? No, I can use Groovy. And I can use Groovy and Java in the same project. It doesn't matter. So I'm going to, let's try and do this live. Okay, so the basic principle is, this is a variant of a JUnit test. I can run it from my IDE as if it were a JUnit test. But it has a structure based on the whole given, when, then. Now, some people will say that's behavior-driven development. Some will say, no, it's just mimics it or something like that. I don't want to get into arguments over the semantics. But basically, the idea is you can specify a descriptive name for this feature method. Say, check, find positives works. Not very descriptive, admittedly, but my imagination's running low at the moment. Okay, and then we do given a new helper, def helper equals new Java, and then I do control space, and it gives me options, although not the ones I want. There we go, Java number helper, voila. So you get auto-completion, even though it's not Java, it is Groovy. Okay, given when I filter a list of numbers, def result equals helper dot, what's the method? Find positives, there we go. 1, 0, -1. That's a list. Okay, so we are allowed list literals. We don't have to do new array list or arrays.as list. We just use square brackets and a list of numbers, and we've got our list. We can even coerce it to an int array so the Java is happy. Okay. And now we then say, then only the positive numbers are returned. And then we just do a standard assertion like so, and we say result equals, what do we think? 1, it is 1. 0 does not class as a positive number in my book. Okay, and now I can just take my number spec, go through the massive pop-up menu, and find the run as option. There we go, run as JUnit test. And boom, it appears to have worked. Let's make sure. Let's say, actually, we expect 0 in there. And then we run it again. Okay. Oh, how cool is this? We're actually given information about every part of the expression that failed. So we know what result is, and we know why equals failed. Okay? Now, one of the issues with unit tests is people tend to, that's it, that's my unit test for the method. Come on, what happens if it's an empty list or null? What if the list only contains negative numbers? These are boundary conditions. These are other data sets. And this is where Spock really shines. So we can say, actually, let's parameterize this. Let's take out the input data and put it into a different block. And we're going to name the input variable input, and what we expect the result is expected. And that's this one. Okay, and now we can say this is what we expect from an empty list. And this is what we expect from just negative numbers, is an empty list. There we go. And then we run it. Let's do it from here, actually. And we see, yeah, there's been a failure. This is great. Has it actually run the other data sets? Are we sure? How do we know which data set failed? in this case, we can tell from the assertion output, but what if we don't have access to that? The answer is a special annotation called unroll. Basically, you should always use @unroll with where blocks. So check find positives works with hash input. Okay, and now when I run it, I get 3 find positives tests. One of them showing as failure. I can see it's the third one. And within that output, it's actually showing my data set. That's the hash input has been expanded with the input data. So it's very easy to see what failed. So, you don't have to use Spock, but Spock has those facilities, the list literals, all the useful closure methods, collect and find all. All of these things make it actually a nicer language to write tests in the first place. You can still do JUnit, but pretty much everyone in the Groovy community is using Spock these days. So if you get the opportunity to see a talk dedicated to Spock, I very much recommend you take a look. Go to that talk. Okay, so, yeah, testing, great. Is there anything, for production code? Well, yeah, question. Is the question, why don't I use assert? Or? Do you mean on this line here? I'm sorry, I'm struggling to hear. Why is there no assert? Or is that asserting? So I'm not quite sure what the question is, but this line here, everything in a then is an implicit assertion. So it will fail if it resolves to anything other than false. This is another feature of Groovy. An empty list resolves to false. It's called Groovy truth. Empty map is equivalent to false. You don't have to do a null object reference equates to false if you're doing a Boolean check. You don't have to explicitly say, does it equal null? One of those annoyances that I forget about until I go back to Java. So yes, implicit assertion. Okay, so I want to demonstrate another example where I've used Groovy in the past, not for the actual production code, but I worked on a project where I wanted to be able to add behavior at runtime. I wanted people to be able to load a Java system to load Groovy code at runtime and execute it. Think plugin systems for text editors. In my case, it was tasks, bits of code running within a workflow system. I didn't want for people to have to build jar files and deploy them with the task executors. So, hey, why not include the code for executing the task in the task definition? This is a trivial example similar to that. The idea here is we have a Java application which has this DSL thing. I'm loath to call it DSL. DSLs have mixed reputations. But basically, there's a buy and sell option, buy and sell shares. Very common example. Each share is an epoch, which is the 3 or 4 character initials for that share, and a quantity. And off to the bottom here, I want to be able to load a trades.groovy file, which basically looks like this. Where is it? Trades.groovy. There we go. Buy 100 of Microsoft, buy 1,000 of Apple. And then I want to be able to see how many shares I have of each at the end of the day. Okay? So the actual app is a Java class. And what I do is load the Groovy script on this line. That basically just takes the file and loads it as a string. Similar to that just .text property we saw earlier. Then this is the interesting bit. We use something called the Groovy shell class to load the script at runtime to give us something that we can execute. And we also pass it this thing called a binding. So if we have a look at create shell quickly, it creates a new Groovy shell with the binding. You can input. You can put data into the binding so it's available to the script. In this case, I don't need to give anything, but I do want to extract that trades variable at the end. So I can run the script with some data and extract data out of it at the end. Okay? And now if I run this, then we'll get the results as we hopefully expect. Run as Java application. There we go, and that's our output. So, you don't have to do something like a DSL, but anything where you want code to load code at runtime, this is a very good way of doing it. Notice this is using a special Groovy feature. This is actually equivalent. Sometimes auto-completion does annoy me a little bit. There we go. That's what it's equivalent to. Call a method by with an argument of 100, and then on the result, call of with a string. Okay? There's some Groovy magic going on behind the scenes, which means I can use that cleaner syntax in the rest. Okay? So we've now seen Groovy scripting, running tests with Groovy, writing tests with Groovy, and using Groovy as a runtime, loading code at runtime and executing it, typically against a Java system of some sort, a workflow system, a trading application, whatever it is. So those are the three core ones. I just really wanted to talk about two last ones, but the main last one is quick sort. So this is when you get to the stage where you're happy to use Groovy in production. And this is the one where most of what you've seen so far is dynamic code. So let me explain quicksort at the moment. Everyone knows the quicksort algorithm, hopefully, or has at least heard of it. I have to say, I just grabbed a version off the internet, as you do, and hope, you hope it works. You don't test it. You just say, hey, it's on the internet. It must work. But that's basically it. It's this horrific code. It's the divide and conquer algorithm. This is a version in Java. I've also got a version in Groovy, called Groovy Quicksort, of course. Pretty much the same code. Slightly Groovified, but not much. And I have a third option, which is Groovy CS. And this uses an annotation called compile static. So the question is, what does this do, this magic annotation? Well, let's have a quick look at what the app does. Refresh that. So our app profiles the Java quicksort, the Groovy quicksort, and the Groovy CS quicksort. So the three variants, it tests them. I'm actually going to return to the terminal, change it into quicksort, and Gradle W, run. There we go. Gradle is another reason to learn Groovy, because the build scripts are pretty much Groovy. It's very easy to write tasks. Okay, so what has this done? Well, ignore the pop-up there for a moment. There we go, cleaned it up. So, the list of numbers, I basically just dump out the first 20 numbers, just so I have some confidence that it's actually sorted the numbers. Okay? So you can kind of ignore that. What's interesting is the time taken. So we are sorting 100,000 numbers, random numbers. It's taken Java 73 milliseconds. It's taken Groovy 157 milliseconds. Groovy compile static 14 milliseconds. Groovy compile static is 5 times faster than Java. You've seen the evidence. Hopefully you realize that you have to be a little bit careful with benchmarks, especially on the JVM, and especially when you're just looking at tens of milliseconds. But it gives you an idea that they're all not too far off. Groovy seems to be double the speed of Java. It gets a little bit more interesting when we pass in, I say 1, 2, 3, 1, 2, 3. There we go, 1 million. I want to sort 1 million numbers. Is Groovy at compile static still going to be 5 times faster than Java? Darn it! No. But we notice now Groovy is noticeably slower. So this is dynamic Groovy. This is standard dynamic Groovy. So Java's 183 seconds. Groovy at compile static is still allegedly faster at 154. But now it's 1.8 seconds, nearly 2 seconds for dynamic Groovy. So yes, you know, Groovy still has a reputation for being slow. It's context dependent. What are you doing? If you're accessing databases lots, that's going to be your bottleneck. If you're doing something highly computationally intensive, such as sorting lists, then yeah, you don't want to use normal dynamic Groovy. It is slower. But it's horses for courses. Okay, so at compile static magically makes Groovy run faster. Basically what happens is all the dynamic features are removed. So every method call is a static lookup, just as it is in Java. So basically you get Java-like performance from Groovy code. On top of that, if you are somebody that has always been a little bit nervous of Groovy, because the compiler doesn't throw an error when you mistype something. For example, let's go back to Groovy Quicksort. What if I try to call test method? It doesn't exist, but the compiler's not going to complain. It's just going to throw a missing method exception at runtime, and that scares people. I don't think it should. I'm comfortable with a dynamic language, but if you are uncomfortable, that's where things like @compile static, why @compile static have been brought in. There's another one called @typechecked as well. This, the IDE, gives you a hint that test method doesn't exist. It's got a great big black underline underneath it. That's the IDE saying, I have no idea what this is about. But if I do that in Groovy CS Quicksort, oh, there we go. I actually get a compile error. And it's a compile error that's popping up in my IDE. So now I'm getting the full Java features if you want static type checking. So I don't really want to go into a debate of whether to use dynamic or static Groovy at this point in time. It's a big discussion. It depends what you're comfortable with. It depends whether you need the speed improvement for @compile static. @typechecked does basically the same thing, gives you static type checking. That's why it didn't autocomplete. There we go, type checked. So I still get the runtime behavior of dynamic Groovy, but I also get compile time type checking. Okay, so I get exactly the same behavior. @compile static actually changes the behavior of Groovy a little bit. Okay, there are some instances where they behave differently. Okay, so there you go. If you have performance critical stuff, you can still use Groovy. You can use @compile static. And if you desperately want compile time type checking, you can use @compile static or @typechecked. I prefer @typechecked unless you need the speed improvement. Okay, and notice this is all happening mixed in. I mean, Java, Groovy. I'm not trying to sell you a replay. It may sound like it, but I'm actually not trying to sell you a replacement for Java. The really great thing about Groovy is it works really well with Java. You can use it as much or as little as you like. It just works seamlessly within Java projects. Okay. So let's just, one last thing. So who was at the Spring Boot talk? Anyone at the Spring Boot talk? Did Josh show a Spring Boot with Groovy, one Groovy file? No. I think he did it in the quickie today. So, what am I talking about? This guy's crazy. Okay, we open up boot app.groovy. This is an entire Spring Boot application. We have a REST controller, and we have one controller action, which is home, which maps to the home URL. I can use, oh, this is where do I have Spring? I can do Spring Run. So, Groovy's giving us a really cheap way of doing very lightweight web services or microservices or the like. And there we go. So if I go to localhost 8080, there we say we get our hello world back. Okay. So to be honest, I don't expect you to write web services that small. It's kind of a nice demo, but it's not going to be something that you do day to day. But you can still use Groovy for Spring Boot controllers in a larger application. But this is just a really neat way of doing something Sinatra-like. If you've ever seen Ruby Sinatra, they just go Ruby and run the script, and boom, they've got a web service that handles stuff. You can do it with Spring Boot now. Very cool stuff. Okay, so I will that is pretty much the demos. So in summary, these are the things that it's pretty good for: the cross-platform scripting, writing tests for actually having runtime dynamic behavior, loading Groovy scripts at runtime, having that seamless integration with Java. Remember, you saw the @grab annotation. That's talking to Maven Central. You can use standard Maven-compatible repositories. And it's still a solid foundation for application development. But again, it's your choice. You can just use it for tests if you want. And it's also part of it has its own ecosystem of very useful tools. I've been using GVM for managing my different versions of Groovy Gradle and Grails. Spock you've seen as the testing framework. Spring has really embraced Groovy, and hopefully you know that Groovy, Pivotal, as they are now, fund the development of Groovy. And you've got the Gradle build tool and the Grails web framework, gparse for doing parallelized stuff. And this is the big news from last week, 2 weeks ago. I can't actually remember. There was a conference in Copenhagen. My memory's hazy. All this traveling around, I just completely lose track of time. But on that day, whenever it was, a week ago, let's say for the sake of argument, it was a week ago, one of the Groovy core developers clicked a merge request button on GitHub and gave Groovy 2.4 beta the ability to run on Android. So does anyone here do Android development? I'm just interested in sort of numbers. So a few people here. If you're interested and would like to look at an example project, I will be up at the Hackergarten table. So it's above the exhibition floor. If you want to have a look, find me there, and I'll show you what's involved in using Groovy for Android. Because Android is behind the times. You can't use Java 8. You can't use Lambda functions. And a lot of the APIs, apparently there's a lot of inner classes and all that stuff. It's not pretty. So it's great news that Groovy, we've taken that first step. You can build an Android app with Groovy. And in fact, @compile static is one of the key enablers of that because it ensures the bytecode is small, the memory footprint is nice and small as well. And the reason this is big news, of course, is because someone comes up with a new language and it's like one corner of the internet knows about it. Apple announced a new language, and I have to shut off Twitter for several days because I just don't want to read about Swift for the umpteenth time. We're kind of hopeful that Groovy will be the Swift for Android. People are used to the Java syntax, but it gives you a lot of the niceties, the sugar coating, some of the features that really make development that much nicer. Okay, and there's a URL with the blog post where Cedric Champeau explains what you need to do to get it running. Okay, so just a few more URLs if you want to find out more: Groovy Docs, Groovy JDK, Groovy Cones. Basically remember that there's an expression: if all you have is a hammer, everything looks like a nail. So if all you have is Java, every problem looks like a Java problem. Increase your tool belt. Add Groovy into the mix. Add other languages to the mix as well. But get rid of Bash. It doesn't do anyone any good. I've done too much Bash in my lifetime. I want those years back. So, but that's the idea. It's an addition to, not a replacement for. So, keep groovying. Thank you very much. And yes, that was it. Thank you. We actually have 5 minutes for questions if anyone has them. We've got a couple at the back there. So, gentleman in the black t-shirt first. The at type checked, yes? Okay, so the question was, does at type check do type inferencing? Well, I can do def L equals a list, like so. I can then do println L dot size, I believe, size. There we go. And I don't have an error. Yes, it has type inferencing. You should be a little bit careful of using def, though, because then Groovy does something called flow typing. So it keeps track of what the type of L is at every point in the code. So if you change the type, it will now know what it is. But if you weren't expecting to change the type, it won't give you a compiler error. But if I actually explicitly say, this is a list, and then try to do something like that, then I get a compile error. But as I say, if I do def, the compile error goes away. So, good question. Gentleman in the green t-shirt. Right, so the question was, if you migrate from Java to Groovy or Spock for doing the tests, is there support for mocking libraries? Absolutely. Spock itself has an internal mocking library, which is very nice, very powerful. But you can still use Mockito. Basically, anything you use in Java, you can use in Groovy as well. So, yeah, if you Mockito, JMock, or any of the others, absolutely fine to use those. Question down here. Okay, so the question is, can everything we do in Bash be done in Groovy? Probably not. Well, you can't integrate with the Bash environment. So you can't load variables into the Bash environment. That's why GVM is written in Bash, because it needs to integrate. But you can pretty much do everything that you need to do outside of that. You don't have like sed and awk and all those things. You can spawn them as external processes, but you have the library methods to do similar things, just in a Java Groovy-like way. Okay? Answer the question. Cool. Any more questions? 2 minutes left. Otherwise. Okay, thank you. I guess I leave you to break time or the next talk. Thank you for coming.